Alright, ladies and gentlemen, welcome to the video notes for Chapter 2, Section 4 in your Algebra 2 textbook. This is one of two videos for that section. So, we're talking about writing linear equations in this section. This should be a review of your Algebra 1 class in theory, but it has been a while since many of us have taken that class. So just as a quick reminder, when we talk about slope-intercept form, point-slope form of a line, we should already know what these things are. Now, it's also more important that we know these things now than it was a few years ago, because these items used to be on the reference sheet for our state exam, the I-step. However, our new state exam, the SAT, the reference sheet does not contain any of this information, so you have to know it. Okay, first of all, slope-intercept form. In slope-intercept form, we have the equation y equals mx plus b, where m is your slope, or your rate of change, and b is your y-intercept. Okay, we should know these things already. Standard form of an equation, ax plus by equals c, that's where these intercepts come in. Remember that the y-intercept is where we cover the x term because we're letting x equal 0. And the x-intercept is where we cover the y term when we graph, because we're letting y equal 0. Okay? And then finally, point slope form, this is the one we haven't really dealt with yet this year. Y minus y1 equals m times the quantity x minus x1, where again, m is your slope, and your x1, y1 is any point on the line. Okay, it doesn't matter what point, you can use any point as x1, y1. So let's go through some basic examples first, and that'll be the end of this video. If we want to write a linear equation in point-slope form, so right away when we see point-slope form, we should write out y minus y1 equals m times x minus x1, where we have a slope of 3. All right, so we have slope of 3. That's going to go in here is the 3. M is 3. And then we have it going through the point 1, 9. That's your x1 and your y1. So we are going to plug 1 in for x1 right there. And we are going to plug 9 in for y1 right there. So when we do that, we will have the equation y minus 9 equals 3 times x minus 1. That does not require any simplification of any type. It is already in point-slope form. Try number 2, then resume the video and see how you did. It's pretty much the same thing. Alright, so point slope form, y minus y1 equals m times x minus x1. Again, we are given a slope right there in the problem. Slope is 1/2. So we're going to plug that m in right there. And then we've got x1 and y1 are given as the point 6, 4. Passes through the point 6, 4. So we're going to plug negative 4 in for y1, and we are going to plug 6 in for x1. So we would be looking at y minus negative 4 equals, slope is 1/2, x minus x1, which is 6. Now in this case, we do have something to simplify, that being these two negative signs right here. When we subtract a negative, that becomes a positive. So the only time you're ever going to have to simplify one of these expressions is when there's a double negative. Okay, on letter C, we are given 2 points instead of a point and a slope. And again, we are asked to write the equation in point-slope form. So the first thing we need to do is take our 2 points, x1, y1, and x2, y2, and find the slope. Remember that we've got the slope formula for that, y2 minus y1 over x2 minus x1. You could also turn these 2 points into a table, find the change in y over change in x. So that would be 15 minus 5 over 8 minus 3. That's 10 divided by 5, or a slope of 2. From there, it's just like the 2 up above it. We are going to plug in the slope, which we just found, for n. And we are going to plug in x1 and y1. Although it technically doesn't have to be that point. You could use the other point as well for your x1 and your y1. So we have y minus 5 equals 2 times x minus 3. Pause the video, try the next one on your own. Again, there are 2 points listed on the graph, so you should be basically doing the same thing we did on letter C. Okay, so the 2 points that we are given on the graph are the points 2, 150, and 3, 190. Now you could do rise over run on the graph, but I'm going to approach this exactly the same way I did the last one, x1, y1, x2, y2. So the slope is y2 minus y1 over x2 minus x1. That would be 190 minus 150 over 3 minus 2, which is 40 divided by 1, so the slope is 40. Okay, from there, we're doing in point slope form again. There it is. So we're doing y minus y1 equals m times x minus x1. We are plugging in the slope of 40 for m. We are plugging in the y1 of 150 for y1, and we are plugging in the x1 of 2 for x1. So that would be y minus 150 equals 40 times x minus 2. You could use the other point as well, so this is one of 2 possible answers for the points we were given in the problem. Okay, next up is example 2, where we are transforming the linear equation after we write it. So we are given in letter A slope and a point. So just like we did on the previous example, we are going to write out the equation in point slope form, PSF, point slope form. Y minus y1 equals m times x minus x1. Again, we've got those values. The slope is 2. We've got x1 is negative 1. And we've got y1 is 5. The point negative 1, 5 is your x1 and your y1. This is x1, this is y1. So we have y minus 5 equals 2 times x minus negative 1. Again, these 2 negatives become 1 positive, giving us an answer for point slope form of y minus 5 equals 2 times x plus 1. We are then going to convert that into slope-intercept form, or SIF. Well, slope-intercept form is y equals mx plus b. So that means we need to solve that equation for y. We need y by itself. That is a 2-step process. First, we distribute the 2, which gives us y minus 5 equals 2x plus 2. And then we need this 5 to move to the other side, so we add 5 to each side to get y by itself. That gives us the slope-intercept form, y equals 2x plus 7. All right, try the next one on your own. Again, pause the video and then resume it to see how you did. All right, once again, we have what we need to plug into point slope form. Y minus y1 equals m times x minus x1. We have the slope that is given in the problem. Slope is 1/2. We have the x1, that is 8. And we have the y1, which is negative 3. So we're looking at y minus negative 3 equals 1/2 times x minus 8. That double negative becomes a positive, meaning our point slope form would be y plus 3 equals 1/2 times the quantity x minus 8. Distribute the 1/2 would give us y plus 3 equals 1/2 x minus 4. 1/2 times negative 8 is negative 4. And then we would move the 3 by subtracting 3 from each side to give us an answer of y equals 1/2 x minus 7. Okay, letter C gives us a slope and an x-intercept. Well, if that's an x-intercept, that means that y is equal to 0. which indicates that this point, x is 9, y is 0, that is the point 9, 0. Okay? When they tell you an x-intercept, they're giving you a point. So that's x1 and y1. Okay, so once again, we have what we need to write out point-slope form. Y minus y1 is m times x minus x1. Slope is given. Slope is negative 2/3. We have the x1 as being 9, and we have the y1 as being 0. It doesn't matter if the point contains a 0, it's still a point, and all you need to write point-slope form is the slope and a point. That would be y minus 0 equals negative 2/3 times x minus 9. Now when we simplify that, it's actually easier than normal, because when we distribute the negative 2/3 and we look at, okay, y minus 0 equals negative 2/3 x plus, and we use our calculator, negative 2/3 times negative 9 is positive 6. This 0 can just be dropped. We don't need to add anything to both sides to get the equation in slope-intercept form, negative 2/3 x plus 6. Okay, then in letter D, we're given 2 points. Those are your x1, y1, and your x2, y2. Your first step should be to find the slope, y2 minus y1 over x2 minus x1. That would be 6 minus 2 over 1 minus negative 1. So your slope is 4 over 2. Meaning your slope is 2. Again, from there, we're plugging in. Doesn't matter which point we use. Okay, but we're plugging in the slope of 2. We're plugging in the x1 value, which I have currently marked as negative 1. And we're plugging in the y1 value, which is 2. Now, you could use 1 and 6 instead. It would make absolutely no difference. So we have y minus 2 equals 2 times x minus negative 1, which means our point-slope form is y minus 2 is 2 times x plus 1. To convert that into slope-intercept, we do the same 2 steps we do every time. We distribute the 2, which gives us y minus 2 is 2x plus 2. And then we add 2 to each side. To get y by itself, which gives us y is 2x plus 4. Okay, letters E and F go back to that the notes from our slope notes where the word parallel and the word perpendicular came up. So when we see the word parallel, that should tell us same slope, which means the slope of the line we're trying to find is the same as the slope of this line, which is attached to x there, that is 2. So we have x1, y1, and m is 2. We go to y minus y1 equals m times x minus x1. And again, we do exactly the same thing we've been doing. We plug the 2 in for the slope. We plug the negative 3 in for the x1. And we plug the 5 in for the y1. So we have there y minus 5 equals 2 times x minus negative 3, or y minus 5 equals 2 times the quantity x plus 3. Distribute the 2 to convert into slope-intercept form. Would give you y minus 5 equals 2x plus 6. And then add 5 to each side to finish converting to get y by itself. Leaves us with y equals 2x plus 11 for slope-intercept form. Okay, this last one is supposed to be tricky. It gives us not only an indirect point, as I like to call it, but it also uses the word perpendicular. So if the y-intercept is negative 10, that means x equals 0 when y equals negative 10. So that's the point 0, negative 10. That's going to be your x1 and your y1. When we see the word perpendicular, we should think negative reciprocal or opposite reciprocal. Slopes. So if we look at this positive 2, The slope of the line we're looking for would be the opposite reciprocal, or negative 1/2. From there, it's the same as all these other ones. Y minus y1 is m times x minus x1. We are going to plug in the negative 1/2 for the slope. We're going to plug in 0 for x1. And we are going to plug in negative 10 for y1. So that would be y minus negative 10 equals negative 1/2 times x minus 0. So the final answer for point slope form is y plus 10 equals negative 1/2 times the quantity x minus 0. We don't really need to distribute there, but we can still think of it that way. The thing about 0 is when I multiply it by negative 1/2, it is still 0, which would give me the equation y plus 10 equals negative 1/2 x. Then I would subtract 10 from each side to get y by itself, giving me the equation y equals negative 1/2 x minus 10. All right, the next video will cover SAT style examples. It's probably not going to be up today as I'm almost out of time in this passing period to record videos, so I'm not going to have time to do the video today. But keep an eye out for that. Remember that on the SAT, the advantage is there's a lot less work. The answers, those are generally multiple choice questions, and the answers that you have to choose from will have various slopes and y-intercepts. So as long as you know how to find the slope or the intercept, you will easily be able to identify which of the 4 answers is the correct answer. So again, what's really important here is that you are comfortable working with point slope form and slope-intercept form, as well as that you've already shown that you know what you're doing with rate of change, which is what we did last section in 2-3. Again, keep an eye out for a second video. Thank you very much for your time and attention.